number 4 states that if two chords are congruent, then their corresponding arcs are congruent. And it's kind of going vice versa. You can switch around and say, if corresponding arcs are congruent, then two chords are congruent. So we'll see how this goes. Number 1, if chords AB, remember chords have endpoints on the circle. So if chords AB and CB are congruent, the measure of arc BC is 140 degrees. What is the measure of angle B? Well, angle B is an inscribed angle. It's going to be half of the intercepted arc, which means it's half of arc AC, so we have to find arc AC. But first, we have to use the theorem. Because these two chords are congruent, if arc BC is 140, then arc BA is also 140. So using that theorem for it. We know that the outside of a circle is 360 degrees, so if we add those 140 together, we get 280. 360 minus 280 gives you 80 degrees. That's the degree measure of arc CA. And then because angle B is an inscribed angle, we are going to take half of the intercepted arc. So we're going to take half of arc CA, and half of 80 degrees is 40 degrees. Let's take a look at the third theorem, which states that if two chords are parallel, then the arcs between them are congruent. So if we look at number 1, it says that, or number 4, I should say, chord CD is parallel to diameter AOB. And the measure of arc AC is 30 degrees. What is the measure of arc CD? Well, using the theorem, if these two chords are parallel, the arcs between them are congruent, so arc DB is 30 degrees. And because angle AOB is the diameter, this right here is a semicircle, 180 degrees. So we can do 30 plus 30 is 60, subtract from 180, and we get the arc CD would be 120 degrees. Next problem, we have a trapezoid, and even though it doesn't say that those two chords are parallel, we know that in a trapezoid the bases are parallel, so AB and DC are parallel. It's inscribed in circle O with diameter DC, so again the diameter is splitting the circle in half. If arc AB is 80 degrees, we have to find arc BC. Well, if we have two parallel chords, the arcs between them are congruent. So we're going to take a semicircle 180. We're going to subtract that 80 degrees up on the top, and we get 140. Or what am I saying? We get 100. Wow, hello. Then those two arcs, because they're the same degree measure, we would just divide by 2, and we get that arc BC is 50 degrees. Number 6, we have AB is parallel to chord CD. So right away we can mark that arc BC is 60 degrees using the theorem. And BD is a diameter, so it goes through the center of the circle O. If the measure of arc AD is 60, what is the measure of angle CDB? Well, if arc BC is 60, and we want to find angle CDB, this is an inscribed angle. An inscribed angle is half of the intercepted arc. So we take half of 60 and we get 30. So angle CDB is 30 degrees. And one more here. In circle O, I'm on number 7. Chords AB and CD are parallel. Now this time it does not go through the diameter. Or it's not a diameter, it doesn't go through the center point. If the measure of arc AB is 104 and the measure of arc CD, so over here, is 168, what is the measure of arc BD? Well, sorry, if we have parallel chords, that means the arcs between them are congruent. And this time we're going to use the full circle. So we're going to add 104 and 168, and we get 272. We would subtract from a full circle 360 and get 88. And because those two arcs are congruent, we would just divide that by 2. So arc BC and arc BD both come out to be 44 degrees.